Alright, so this is our review for our quiz tomorrow. Remember to subtract, you need to distribute the negative sign through, and then you just combine your like terms with the real and the imaginary parts. So we would end up with a negative 4 minus 14i. Make sure you write it in the form of a plus or minus bi. So the second one, we're just going to combine like terms. 8i minus 6i is 2i. And then, again, combine like terms and write it in the form a plus or minus bi. So we would have 8 plus 8i. Alright, so remember we have to use our rules here to multiply. So 7i times 3i gives us 21i squared, and the I squared, remember, equals negative 1. So we can simplify that down to be negative 21 times 8i. And then we will end up with negative 168i. Remember, you should never have an exponent other than 1 on an I. Right, so number 4, we should do the box method, FOIL, however you want to think about it, distributive property. So we can do first times first, and we would get 6. Then we go to outer, and we would get 24i. And then we do inner, we get positive 2i, and then last times last gives us positive 8i squared. And then we would want to change that I squared to a negative 1, so we would make that a negative 8. And we can go and combine the 24i and 2i and make it 26i. Now we can just do 6 minus 8. Gives us a negative 2 plus 26i. Again, make sure you write it in the form a plus or minus bi. So 45, we're going to do 7i times 7i, which gives us 49i squared, which is really negative 49. And then we just have to distribute the negative 49 to the negative 7 and the positive 7i. And that would give us 343 minus 343i. Alright, so at number 6, we can't have an I in the denominator, so we need to multiply the top and the bottom by an I. That's what we do. We have a monomial in the denominator. So we distribute, we get 5i plus 4i squared. And then in the denominator, we would end up with 9i squared. Now we want to replace our I squareds with negative 1. So we would have a negative 4 plus 5i in our numerator. And we would change the 9i squared to negative 9. Now we want to also get rid of the negative in our denominator and break it apart so we have it in the form of a plus or minus bi. So we'd have positive 4 ninths minus 5 ninths I. So with number 7, we want to remember we want to multiply by the conjugate. So that would be 9 minus 6i on the top and bottom. So we're going to need to distribute 2i through to 9 and negative 6i in our numerator. And that will give us 18i minus 12i squared. And remember, conjugates, if you think of it as FOIL, the outer and inner terms always cancel each other out. So really we just have to do the first times first, 9 times 9, which would give us 81. And then last times last, which would give us negative 36i squared. And then we're going to replace our I squareds with a negative 1. So that means our numerator becomes positive 12 plus 18i. And then we would have 81 plus 36, which is 117. So now we want to break it apart. So we have our A and our B value, and then we're going to replace our fractions. So we can divide the first top and bottom by 3, and we make it 4 over 39. And we can divide 18 and 117 by 9 and make it 2/13. Alright, so remember to graph, your A value is which direction you move, left or right. So -5 means we would go left 5, and then the B value, -4, means we go down 4. So we should also be able to locate a point. So notice we go over 2, down 1. So it would be 2 minus 1i. Alright, so factoring. So remember, when we factor, we want to get it equal to 0 every time. So with this one, we'd have a squared plus 2a. We look for our greatest common factor here. They both share an a, so we are going to factor an a out. And we would have a times the quantity a plus 2. So now we got to set both of these parts equal to 0. So a equals 0 and a plus 2 equals 0. So we have one of the solutions, a equals 0. So the second one, we just got to subtract 2 from both sides, and we get a equals -2. That is our two solutions. So number 11, we got to subtract 42 from both sides. So since the a value is 1 here, we're just looking for two numbers that multiply together gives -42, but add be -1. And those two numbers are -7 and +6. So we would fill in, and then we just have to see what makes them 0. So +7 would make the first binomial 0, so x equals 7, and -6 makes the second binomial 0, so x equals -6. So our next solution, we are going to use completing the square. So we want to get the c to the other side, so we just have n squared plus 14n on one side. So now we take half of 14, which is 7, then square it. It's 49. That's the number we need to complete the square. So we will add that to both sides. So now we know that trinomial factors to n plus 7 quantity squared. So now we can take the square root of both sides. Remember to put plus and minus by the square root of 62. And we're left with n plus 7 equals positive and negative radicals 62. So we should check to see if there's any perfect squares in 62. And we just divide it by 2 because we see it's even, and we'll see that we get 2 times 31. So 31's prime, so there's no perfect square there. So the last step is to just subtract 7 from both sides to get our two exact solutions. Alright, last problem. Notice the b value in this problem is 0, so we just want to get x squared by itself and then take the square root. So we add 1 to both sides, and then we want to divide both sides by 4. So we end up with x squared equals 28. So we take the square root of both sides. Don't forget our plus and minus. We want to look for a perfect square in 28. Well, 28 is 4 times 7. So we take square root of 4 and get 2, and we keep the 7 in the radical. There's our two solutions.